Today, we're exploring a technique that reveals a material's hidden electrical secrets. It's called EIS.
So how do you see what's happening inside something without, actually cutting it open?
Well, think of it like sonar. You send a little signal in and just listen for the echo. This powerful tool has a name: electrical impedance spectroscopy, or for short, EIS.
Now to get this, you first have to understand impedance. And trust me, it's more than just resistance. See, resistance is for steady, direct current, but impedance handles alternating current, and it actually changes.
Impedance isn't just one thing. It's actually a combination of 3 different electrical properties all working together.
So, how's it done? The process is super precise, kind of like a detective working a crime scene.
First up, you have to get rid of any background noise that could totally mess up your evidence.
We do this with the 2-step compensation. It's all about getting the instrument perfectly zeroed out.
All right, the instrument is calibrated. Now it's time to actually bring in our sample.
And preparing the sample is vital. Every little detail has to be just right to get a good reading. So the scan spits out a ton of data. The trick is to plot it all on a graph.
And what you'll often see is this distinct curve. It shows the material's ability to store charge.
To really understand this graph, scientists look at 3 key regions. Each one tells a different story.
But getting clean data is tough. You really have to control every part of the experiment.
Okay, so we know how it works, but what's this actually used for in the real world?
The applications are pretty amazing, from testing food freshness to detecting corrosion and developing new biomaterials.
At its core, it helps us understand that invisible boundary where 2 different materials actually meet.
It's really a window into the secret electrical life that's happening deep inside almost any material.
And by scanning across a huge range of frequencies, we get a complete and really detailed picture.
So, the main takeaway? EIS is an incredibly sensitive tool for seeing what's normally completely invisible.
Makes you wonder, as this technology gets even better, what other mysteries is it going to solve?